Hello, I am back with you reading Python Programming by John Zelle. This is the third edition. So if you would like to read along, we are going to be reading chapter 4, starting on page 83. The chapter is called Objects and Graphics, and we start with some objectives under the first bullet point to understand the concept of objects and how they can be used to simplify programming. Second bullet, to become familiar with the various objects available in the graphics library, and then to be able to create objects in programs and call appropriate methods to perform graphical computations. After that, to understand the fundamental concepts of computer graphics, especially the role of coordinate systems and coordinate transformations. Then, to understand how to work with both mouse and text-based input in a graphical programming context. And finally, to be able to write simple interactive graphics programs using the graphics library. Section 4.1 is an overview. So far, we have been writing programs that use the built-in Python data types for numbers and strings. We saw that each data type could represent a certain set of values, and each had a set of associated operations. Basically, we viewed the data as passive entities that were manipulated and combined via active operations. This is a traditional way to view computation. To build complex systems, however, it helps to take a richer view of the relationship between data and operations. Most modern computer programs are built using an object-oriented approach. Object orientation is not easily defined. It encompasses a number of principles for designing and implementing software, principles that we will return to numerous times throughout the course of this book. This chapter provides a basic introduction to object concepts by way of some computer graphics. Graphical programming is a lot of fun and provides a great vehicle for learning about objects. In the process, you will also learn the principles of computer graphics that underlie many modern computer applications. Most of the applications that you are familiar with probably have a so-called graphical user interface, or a GUI, that provides visual elements like windows, icons, represented pictures, buttons, and menus. Interactive graphics programming can be very complicated. Entire textbooks are devoted to the intricacies of graphics and graphical interfaces. Industrial strength GUI applications are usually developed using a dedicated graphics programming framework. Python comes with its own standard GUI module called tkinter. I think that's how to say it, or tkinter. As GUI frameworks go, tkinter is one of the simplest to use, and Python is a great language for developing real-world GUIs. Still, at this point in your programming career, it would be a challenge to learn the intricacies of any GUI framework, and doing so would not contribute much to the main objective of this chapter, which are to introduce you to objects and the fundamental principles of computer graphics. Yes, I know I missed the S there. To make learning these basic concepts easier, we will use a graphics library called graphics.py, specifically written for use with this textbook. This library is a wrapper around tkinter that makes it more suitable for beginning programmers. It is freely available as a Python module file, and you are welcome to use it as you see fit. Eventually, you may want to study the code for the library itself as a stepping stone to learning how to program directly in tkinter. Sorry for tipping. So the footnote there says the graphics module is available from this book's support website. Now we have section 4.2, the object of objects. The basic idea of object-oriented development is to view a complex system as the interaction of simpler objects. The word objects is being used here in a specific technical sense. Part of the challenge of OO programming is figuring out the vocabulary. You can think of an OO object as a sort of active data type that combines both data and operations. To put it simply, objects know stuff. They contain data and they can do stuff. They have operations. Objects interact by sending each other messages. A message is simply a request for an object to perform one of its operations. Consider a simple example. Suppose we want to develop a data processing system for a college or university. We will need to keep track of considerable information. For starters, we must keep records on the students who attend the school. Each student could be represented in the program as an object. A student object would contain certain data, such as name, ID number, courses taken, campus address, home address, GPA, etc. Each student object would also be able to respond to certain requests. For example, to send out a mailing, we would need to print an address for each student. This task might be handled by a print campus address operation. When a particular student object is sent the print campus address message, it prints out its own address. To print out all the addresses, would loop through the collection of student objects and send each one in turn the print campus address message. Objects may refer to other objects. In our example, each course in the college might also be represented by an object. Course objects would know things such as who the instructor is, what students are in the course, what the prerequisites are, and when and where the course meets. One example operation might be add student, which causes a student to be enrolled in the course. The student being enrolled would be represented by the appropriate student object. Instructors would be another kind of object, as well as rooms and even times. You can see how successive refinement of these ideas could lead to a rather sophisticated model of the information structure of the college. As a beginning programmer, you're probably not yet ready to tackle a college information system. For now, we'll study objects in the context of some simple graphics programming. This is chapter 4.3, Simple Graphics Programming. In order to run the graphical program, the examples in this chapter and the rest of the book, you will need a copy of the file graphics.py that is supplied with the supplemental materials. Using the graphics library is as easy as placing a copy of the graphics.py file in the same folder as your graphics programs. Alternatively, you can place it in a system directory where other Python libraries are stored so that it can be used from any folder on the system. The graphics library makes it easy to experiment with graphics interactively and write simple graphics programs. As you do, you will be learning principles of object-oriented programming and computer graphics that can be applied in more sophisticated graphical programming environments. The details of the graphics module will be explored in later sections. Here, we'll concentrate on a basic hands-on introduction to whet your appetite. As usual, the best way to start learning new concepts is to roll up your sleeves and try out some examples. The first step is to import the graphics module. Assuming you have placed graphics.py in an appropriate place, you can import the graphics commands into an interactive Python session. If you are using idle, you may have to first point idle to the folder where you have saved graphics.py. A simple way to do this is to load and run one of your existing programs from that folder. Then you should be able to import graphics into the shell window. Here is some code. Arrow, 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 import graphics. New line, arrow, arrow, arrow. If this import fails, it means that Python couldn't find the graphics module. Make sure the file is in the correct folder and then try again. Next, we need to create a place on the screen where the graphics will appear. That place is a graphics window or GraphWin, which is provided by graphics. Here's some code. Arrow, 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 win equals graphics.graphwin, open parentheses, close parentheses, new line, arrow, arrow, arrow. Notice the use of dot notation to invoke the GraphWin function that quote unquote lives in the graphics library. This is analogous to when we used math.square-root, x inside parentheses, to invoke the square root function from the math library module. The GraphWin, open parentheses, close parentheses, function creates a new window on the screen. The window will have the title graphics window, quote unquote. The GraphWin may overlap your Python shell window, so you might have to resize or move the shell to make both windows fully visible. Figure 4.1 shows you an example of a screen view. So I will show figure 4.1 to you from the book. And so you can see both windows can be seen side by side. Both are open and both are fully visible. They are not overlapping at all. The GraphWin is an object, and we have assigned it to the variable called win. We can now manipulate the window object through this variable. For example, when we are finished with a window, we can destroy it. This is done by issuing the close command. It's coded this way: arrow, 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 win.close, empty parentheses, new line, arrow, arrow, arrow. Typing this command causes the window to vanish from the screen. Notice that we are again using the dot notation, but now we are using it with a variable name, not a module name, on the left side of the dot. Recall that win was earlier assigned as an object of type GraphWin. One of the things a GraphWin object can do is to close itself. You can think of this command as invoking the close operation that is associated with this particular window. The result is that the window disappears from the screen. By the way, I should mention here that trying out graphics commands interactively like this may be tricky in some environments. If you are using a shell within IDE, such as idle, it is possible that on your particular platform, a graphics window appears non-responsive. For example, you may see a quote-unquote busy cursor when you mouse over the window, and you may not be able to drag the window to position it. In some cases, your graphics window might be completely hidden underneath the IDE, and you have to go searching for it. These glitches are due to the IDE and the graphics window both striving to be in control of your interactions. Regardless of any difficulties you might have playing with the graphics interactively, rest assured that your programs making use of the graphics library should run just fine in most standard environments. They will definitely work under Windows, Mac OS, and Linux. We will be using quite a few commands from the graphics library, and it gets tedious having to type the graphics notation every time we use one. Python has an alternative form of import that can help out. It's coded this way: from graphics import asterisk. The from statement allows you to load specific definitions from the library module. You can either list the names of definitions to be imported or use an asterisk as shown to import everything defined in the module. The imported commands become directly available without having to preface them with the module name. After doing this import, we can create a GraphWin more simply. Win equals GraphWin, empty parentheses. All the rest of the graphics examples will assume that the entire graphics module has been imported using from. Let's try our hand at some drawing. Graphics window is actually a collection of tiny points called pixels. This is short for pixel elements. By controlling the color of each pixel, we control what it displays on the window. By default, a graph win is 200 pixels tall and 200 pixels wide. That means there are 40,000 pixels in the graph win. Drawing a picture by assigning a color to each individual pixel would be a daunting challenge. Instead, we will rely on a library of graphical objects. Each type of object does its own bookkeeping and knows how to draw itself into a graph win. The simplest object in the graphics module is a point. In geometry, a point is a location in space. A point is located by reference to a coordinate system. Our graphics object point is similar. It can represent a location in a graph win. We define a point by supplying x and y coordinates, open parentheses, x comma y, end parentheses. The x value represents the horizontal location of the point, and the y value represents the vertical. Traditionally, graphics programmers locate the point 0, 0 in the upper left-hand corner of the window. Thus, x values increase from left to right, and y values increase from top to bottom. In the default 200 by 200 graph win, the lower right-hand corner has the coordinates 199, 199. Drawing a point sets the color of the corresponding pixel in the graph win. The default color for drawing is black. Here is a sample interaction with Python illustrating the use of points. All right, we're on page 89. At the top, we have some code. Arrow, 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 p equals point, 50, 60, inside parentheses. New line, arrow, 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 p dot get x, empty parentheses, new line 50. New line, arrow, 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 p dot get y, empty parentheses, new line 60. New line, arrow, 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 win equals graph win, empty parentheses, new line, arrow, 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 p dot draw win inside parentheses, new line, arrow, 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 p2 equals point 140, 100 inside parentheses, new line, arrow, 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 p2 dot draw win inside parentheses. The first line creates a point located at 100, 200. After the point has been created, its coordinate values can be accessed by the operation getX and getY. As with all function calls, make sure to put the parentheses on the end when you are attempting to use the operations. A point is drawn into a window using the draw operation. In this example, two different point objects, P and P2, are created and drawn into the graph win called win. Figure 4.2 shows the resulting graphical output. So here in figure 4.2, you can see, if I get in close enough, that there are 2 points on that window, 2 little dots at their proper coordinates. I hope you can follow along in your book on page 89. In addition to points, the graphics library contains commands for drawing lines, circles, rectangles, ovals, polygons, and text. Each of these objects is created and drawn in a similar fashion. Here is a sample interaction to draw various shapes into a graph win. Here we have some code on page 90. Arrow, 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 hashtag, 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 hashtag. Open a graphics window. New line, arrow, 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 win equals graph win, open parentheses, single quote, shapes, end single quote, end parentheses. New line, arrow, 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 hashtag, 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 hashtag. Draw a red circle centered at point 100, 100 with radius 30. New line, arrow, 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 center equals point 100, 100 inside parentheses. New line, arrow, 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 CIRC for circle equals circle, open parentheses, center, comma, 30, end parentheses. New line, arrow, 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 circ dot set fill, open parentheses, single quote, red, end single quote, end parentheses. New line, arrow, 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 circ dot draw, open parentheses, win, close parentheses. New line, arrow, 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 hashtag, 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 hashtag. Put a textual label in the center of the circle. New line, arrow, 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 label equals text, open parentheses, center, comma, quote, red, circle, end quote, end parentheses. New line, arrow, 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 label dot draw, open parentheses, win, close parentheses. New line, arrow, arrow, arrow. What is this called again? Hashtag, 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 hashtag. Draw a square using a rectangle object. New line, arrow, 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 rect equals rectangle, open parentheses, point, open parentheses, 30, comma, 30, end parentheses, comma, point, open parentheses, 70, comma, 70, end parentheses, end parentheses. New line, arrow, 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 rect, dot, draw, open parentheses, win, close parentheses. New line, arrow, 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 hashtag, 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 hashtag. Draw a line segment using a line object. New line, arrow, 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 line equals line, open parentheses, point, open parentheses, 20, comma, 30, end parentheses, comma, point, open parentheses, 180, comma, 165, end parentheses, end parentheses. New line, arrow, 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 line dot draw, win inside parentheses, new line, arrow, 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 hashtag, 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 hashtag. Draw an oval using the oval object. New line, arrow, 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 oval equals oval, open parentheses, point, open parentheses, 20, comma, 150, end parentheses, comma, point, open parentheses, 180, comma, 199, end parentheses, end parentheses. New line, arrow, 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 oval, dot, draw, open parentheses, win, end parentheses. Trying to figure out what each of these statements does, if you type them in as shown, the final result will look like figure 4.3. I will show you the figure at the bottom of page 90 of the book. You can see there a square, a circle, a line, and an oval according to the code that was read above. Oh, no, on this side. According to the code we just read. I will continue with section 4.4 in a following video. I'm going to end now. I'll see you in the next one.